Okay, this is 6.1, solving inequalities by addition and subtraction. Okay, first just the addition and subtraction properties. It says for all numbers a, b, and c. If you already know that a is less than b, then you can go ahead and add some number c. You can go ahead and add a little c to each side. As long as you do it to both sides, your inequality is going to still be true. A is still going to be less than B, or actually that quantity is still going to be less than that quantity on the right. If A starts off, this one here, if A starts off greater than B, then again you can go ahead and add something to both sides and your inequality is still true. And then for subtraction, same thing. As long as you subtract from both sides the same exact amount, your inequality will remain true. You won't have messed up anything. So this whole slide is just saying you can add and subtract anything you like as long as you do it to both sides of the inequality. Just like with equations, when we tried to keep those in balance, well, these aren't perfectly equal on both sides, but at least the inequality remains true. All right. There are some clue words because sometimes we'll have to translate the words into inequalities and numbers. So if you see words like less than, then it's going to look like this symbol here. This is considered a less than symbol. Okay. And then fewer than, same thing. It's going to use that symbol. Greater than, this is the greater than symbol. When it opens this way, we call it greater than. Or if we see the words more than, same thing. The green one here, we're going to use that when we hear words like at most. They're going to give us at most $5. That means less than or equal to. So that's the most you're going to get. Oops, didn't want to change that color. So that's at most. It's also no more than. And it's also less than or equal to. So the or equal to is the bar underneath it. And then the greater than. This symbol here, greater than or equal to, we use this when we want to say at least, or we also use it for no less than. And then maybe the most obvious is the greater than or equal to. So it has a bar underneath it. Greater than or equal to. All right, let's get into a few examples. Directions will say something like solve, and then check your answer, and then also graph the solution on the number line. So here's the inequality. We use our exact same skills that we used when we were solving equations. We're just trying to get the variable by itself, trying to get the variable isolated. So you can add and subtract to both sides, just like we saw. So it's a minus 8, so of course I'm going to add 8 to both sides. And that's going to cancel out the 8's, and that's going to leave me with n. And this says is less than, so n is less than, and negative 13 plus 8, that should be negative 5. So now when I go to graph this on a number line, actually I should probably check it. So n is less than negative 5. So maybe I could, try to pick a number that's less than negative 5. So let's do maybe a little check and see if we can try a number. So a number less than negative 5 would be like maybe negative 6. So let's try negative 6. So negative 6, let's go ahead and put it in for the variable and see if it would be true. So let's go negative 6 minus 8, and let's see if that's less than negative 13. Negative 6 minus 8, that'd be negative 14, and that would be less than negative 13. That's true. So we're probably on the right track here with this solution. So let's go ahead and graph it. n is less than negative 5, so need a little bit of a reference. So you might want to put some points in here, like maybe 0, negative 1, negative 2, negative 3, negative 4, negative 5. It says that n is less than negative 5, so you have to know if it's an open circle or a closed circle when you're graphing. So if it doesn't have a bar underneath it, so if it's like this, either way, it's open. And then if it does have a bar, where it has this bar underneath, then that's a closed circle. Open circle, closed circle, or dot, you could say. Okay, so that's going to be true the whole chapter, or the first several sections anyway. All right, so this is an open circle. So we go open, and it says less than -5. So the numbers that are less than -5 are to the left. So then we would just graph everything to the left. Okay? And what this shows is that all the numbers to the left of -5 would actually satisfy this inequality. All right. Next one. Same direction, so we're going to try to get the variable by itself. This time it's the variable k. So we just need to do whatever it takes to get them by themselves. You can either add the 9k to both sides, or we can add the 8k. I think I'm going to go ahead and add the 9k to both sides, just so that my k turns out to be positive. So I'm going to add 9k, and if I do that, I cancel from this side. And when I add these guys together, I'm going to have a positive k minus 12 is less than, and I won't have anything over there, so I'm going to say 0. And then I'm going to add 12, and that will be k is less than, and then it'll be 12. So we could check this, try a number that's less than 12, like maybe 11. So we can do a little check off to the side. Let's try 11, see if it would work. So I take 11 and I plug it in. Actually, that's a little pain to plug in, but go ahead and plug it in for the k. So that means I'd have to do -8 times 11 minus 12, and then is less than -9 times 11. So this would be -88 minus 12 is less than -99. So -88 minus 12, so that's even more negative. So it looks like it's probably -100. Is that really less than -99? Well, yeah, it is, because it's further to the left. So this is another true statement. Okay. So let's go ahead and plot this. So 12, let's see, I guess I'll put in my reference point of maybe 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You can, different people make different graphs, but you got to have at least some numbers in there so you know where you're at. And again, open circle at 12. So open circle at 12. And it's got to be less than all the numbers to the left. Okay? Again, if I had a bar underneath it, then I would go ahead and close in that dot. So I probably should have picked one that was that. All right, next type of problem. It says define a variable, write an inequality, and solve the problem. So we're just doing a little translating, making it an inequality, and then going ahead and solving the inequality. All right, so a number. So first thing, we have to figure out what variable we want to use. We could use whatever we want. So let's just say, let's use n, just to be different. So let's use n. So n is our variable. Decreased by 4. So we got to know that that's -4. And then is less than. Wow, I got too many of the same. So is less than is going to be this. And then 14. And then we're going to solve for n. So we're going to have to add 4. And so n will be less than, it looks like, 18. So that would be my answer. Some people will use set builder notation. It's called set builder notation. So they might have a set notation. They might say the answer is the set of all n such that n is less than 18. You might see that on standardized tests, or maybe some of your teachers' tests, homework, etc. Okay? All right, let's try another guy. The sum of a number and 8, so we got to pick the letter that we want to use again. So maybe we could just use the letter n for the number. So the sum of a number and 8, so we know that sum deals with plus. So we got n plus 8 is less than, oh goodness, I got too many of the same. So is less than 12. So I got n plus 8 is less than 12. And I'm going to subtract 8. And I've got n is less than 4. Wow, I was really loving the less thans. Didn't even notice that till now. So let's see. I think we'll probably be pretty good there. I like some of the applications after we learn a little bit more. After 6.2, the applications get a little bit better. They're real basic right now. We're just adding a little bit and subtracting from each side. Okay? Let me make sure we're okay. Okay. Yeah, I think that'll be fine.